special symmetries, even functions and odd functions. So first, an even function is a function that is symmetric about the y-axis. So the y-axis is our vertical axis. And so this is saying if you were to fold the graph along the y-axis, the two sides would match up. So this means for points on our graph, if they have the opposite x value, they will have the same y value. Think about an example. If the point 2,5 is on your graph and you have an even function, then it means you will also have the point -2,5. So they have opposite x values but the same y value. Algebraically, the way that we can write this is that f of -x is equal to f of x. So the inputs, -x and x, are opposites, and this is saying that the outputs will be equal. Odd functions have a special type of symmetry called point symmetry. So they are symmetric, but they are symmetric about the origin. So rather than a line for symmetry, we have a point symmetry. So what happens in an odd function is that when we have opposite x values, we're actually also going to have opposite y values. So opposite x will give us opposite y. So think about an example for that. So if we use the same point 2,5 on an odd function, this means that we'll also have the point -2, -5. So opposite x values and opposite y values. Algebraically, the way that we can write this is that f of -x is going to be the opposite of f of x. So if the inputs are opposites, -x and x, then the outputs will also be opposites, is what that negative on the outside is showing us. So let's think about our 9 toolkit functions and see where they would fall. So to do this, think about the graph of each function and the shape of that graph and whether or not we would have any symmetry. So thinking first about even functions, our constant function would be an example of an even function. Remember, our constant function is a horizontal line, and so that would be symmetric about the y-axis. Another even function would be our quadratic function. So our quadratic function is our U-shaped parabola with its vertex at the origin. So if we folded that along the y-axis, the two sides would match up. Another even function is our absolute value graph. Same reason, it's a V shape instead of a U shape, but it again has its vertex right at the origin. And then also our reciprocal squared function. So this was one of our rational functions. And so the left side was above the x-axis and the right side was above. So this was one, it does not exist for x equals 0, but the two sides would still match up with symmetry about the y-axis. How about our odd functions? So thinking about our toolkit functions, the identity function is an example of an odd function. So this is our simplest linear function. It's a line with a slope of 1 that goes through 0, 0 as its y-intercept. So it's symmetric about the origin and that each point, if they have opposite x values, they will also have opposite y values. Our cubic function is an odd function. So our cubic function is that S-shaped curve going through the origin. So we have, for example, the point 2, 8, and then also -2, -8. And cube root then will also be odd. Similar shape, it's more of kind of a sideways looking S, but it's just the flip of all those points that we see on our cubic function. We have one more odd function, and that is our reciprocal function. So this one has one piece down in quadrant 3 and one piece in quadrant 1. This one doesn't go through the origin because it doesn't exist for x equals 0. It's undefined there, but we still get symmetry about the origin in all of our points, and so that kind of diagonal type of symmetry. So that covers 8 of our toolkit functions. We have one that is neither even nor odd. And so that function that we have left is our square root graph. So if you think about the graph of our square root function, it only exists for positive values of x. Because of that, we don't have that symmetry with opposite x values, so it's neither even nor odd. So when we're thinking about even and odd functions, we can think about their symmetry, about either the y-axis or the origin, and then come back to thinking about how that affects our inputs and our outputs. So if you have opposite inputs, does that give you the same output or opposite outputs to determine if we have an even or an odd function?